Propene and butene are used in the petrochemical industry to produce important polymers. Explain the term polymer. Well, a polymer is a compound made by addition reaction from smaller monomer units. So there you go. Polypropene does not have a sharp melting point temperature, but softens over a wide temperature range. Why is this? Well, these polymers, they're not pure compounds. Pure compounds melt in a sharp melting point, have a sharp melting point. Whereas polymers aren't. They are a mixture of things, and they vary in chain length. So you get some really long chains and you get some shorter chains. And you also get branched material. And all those materials will have different melting temperatures. And so when you lump them all together, you're going to get something that melts over a range and doesn't have a sharp melting temperature like a pure compound would. Draw a section of the polymer formed from butene showing 2 repeat units. So we'll do that the way it's been recommended on the course. So with butene, so with an alkene when you're doing this, then the thing to do is to do the double bond, the carbon to carbon double bond horizontal like that, and then to put the 4 groups on like this. Now with butene, because it's bute, it's monkeys eat peanut butter, it's 4 carbons long, so we're going to have a CH3 group up here, a CH3 group up here, and a H here, and a H here. Those are going to be our 4 groups that are attached to the carbons on the carbon-carbon double bond. Now when we're asked to make the repeat units, what we need to do is we need to imagine that these double bond springs open, a bit like arms unlinking, and then you end up with this. I'm going to draw it out exactly as it is over there, with the difference that the double bond has sprung open like that. So that is a repeat unit. Now it's asking us to draw from 2 repeat units. So the way we can do that is, and it's quite easy on a computer really, is we can just copy and paste it. So if we go edit and we go copy and then we go paste like that, we can take our 2 units and link them together like that. So what we should do, that's our 2 repeat units, and what we can do if we want to is put the brackets around and put an N to one side to show that the polymer is made up of those units. But that's the way to do it. Let's get rid of that now. Give 2 ways in which chemists contribute to a more sustainable use of materials such as polypropene. Well, you can actually burn the waste polymer and use it to make energy, so you're putting the waste to good use, you're not just burying it. You can also use it and break it down in like a cracking reaction like you do with crude oil, long chain crude oil, to make shorter chain materials which can be used for chemical feedstocks. So, or alternatively, you can get it sorted, waste material sorted and recycled like they do at a lot of these recycling centres these days. Butene can be converted to buta-1,3-diene by a process called dehydrogenation. Buta-1,3-diene is used to make synthetic rubber. Draw a structure of buta-1,2-diene. Right, so bute means it's got 4 carbons. Monkeys eat peanut butter, 4 carbons. And the diene means it's got 2 carbon-to-carbon double bonds. And they're in positions 1 and 3 on the carbon chain. So if we just do a 4 carbon chain, that's our bute, and we will put our double bonds in positions on carbon 1, so that's 1, 2, 3, and position 3. And now it's just a case of adding the hydrogens on, and we just have to make sure that each carbon's got 4 bonds. So this carbon's got 4 bonds there, that's 1, 2, 3, 4, that one has now 1, 2, 3, 4, and this one's got 4 on like that, and we can just add the hydrogens on like that.